Hi, welcome to the presentation of the paper titled Facial Action Unit Detection with Transformers. I am Geetu Miriam Jacob and this paper is co-authored by Bjorn Stenger and we are from the Rakuten Institute of Technology. The Facial Action Coding System, or FACS, refers to a set of facial muscle movements that corresponds to a displayed emotion. This coding system was introduced by Ekman and Rosenberg in 1997. There are several applications in real world such as psychopathy and photography where facial action unit detection has been proved to be helpful. The problem of facial action unit detection is a multi-labeled classification problem. The approach proposed in the paper is based on two specific observations. The first is that each FAU has got a specific region of the face associated with it. And the second is that for each facial expression, the FAUs are correlated. Based on these observations, a two-level attention approach is proposed in the paper. The first level of attention, termed as region of interest attention, or ROI attention, focuses on the spatial region of each FAU in the face. The second level of attention is based on self-attention, where we leverage the correlations between the FAUs. Some existing works like EACnet and JARNet focuses only on the spatial attention, whereas other works like SRERL focuses only on the correlations between FAUs. We propose an architecture which computes the spatial attention as well as the correlations between FAUs. The proposed architecture consists of four components, namely the feature extractor, ROI attention module, per AU embeddings module, and AU correlation module. We use an Inception V3 model pre-trained on ImageNet as the feature extractor here. ROI attention module is built on the concept of attention branch networks. The module takes features as input and learns attention maps for each action unit along with the labels associated with the face image. There are two loss functions associated with this module. In the first loss function, we provide a supervision on the attention map. The ground truth for the attention map is created using facial landmarks. The second loss function is for the labels, where a combination of cross-entropy loss and Tversky loss are used for providing supervision for the labels. Per AU embeddings module is basically a branched multitask network where each branch learned features specific to each FAU. Here the learned attention maps from the ROI attention module are weighted with the feature maps and provided as input to the module. The FAU specific features are concatenated together and the proposed center contrastive loss makes them discriminative in nature. The center contrastive loss formulation basically minimizes the intra-class variations while maximizing the inter-class variations of features. The AU correlation module leverages the information of correlations between the FAUs. The module consists of layers of transformer encoder. The discriminative features are fed to the transformer encoder along with the positional encoding. The multi-head attention computes self-attention, which estimates the importance of one FAU with respect to the other in each facial expression. The correlated features are now passed through an MLP consisting of fully connected layers, thus learning labels from the correlated and distinctive features. The loss function again is a combination of cross-entropy loss and Tversky loss. The performance of our model on BP4D dataset with 12 FAUs are shown in the figure. The last column shows the results of our method. On an average, our model performs the best with a 2% increase in the F1 score. Similarly, on the DISPA dataset, our method performs the best on an average. There are several ablation studies reported in the paper. I quote the most important study here. The biggest contributors of our method, as per our study, are the multitask branch structure with pre-trained features, then the transformer encoder, and then the attention branch. Some qualitative results on EmotionNet are shown here. The first row shows the input images, the second row shows the ground truth of combined attention map of the active FAUs, and the third row shows the combined attention map of the active FAUs generated by the ROI attention module. It is observed that the generated attention map resembles the ground truth map to a great extent. Thank you for watching. For any queries, I welcome you all to the poster session.